Hi, my name is Peter McTavish and welcome back to another DCG tutorial. The last video we did, we finished off part A of this C-4 dynamic mechanisms question from the ordinate level. So this is 2010 section C, question C4 part B. As always, read through the question, see what they're asking you to do, and give as much information of it as you can. A trundle wheel, as shown in a 3D graphic on the right, is often used to measure distances by rolling it along the ground. In figure C4b below, circle C represents the wheel. In the diagram, circle C rolls clockwise along the line AB for one full revolution. Plot the locus of point P for this movement. So this is a locus question, find the locus of point P. And first things first, always draw what's given, draw what's there. We have our ground line AB, we have our diameter 60 circle C, and we also have our point B. So let's put that in first. Okay, so that's what we've been given. We've been given the circle C, point P on the ground, and the line AB. It says one full revolution. So again, if it's a circle and you have one full revolution, you must divide it up 30-60. So divide up that circle 30-60 now. Now I'm just zoomed in on the circle for 2 seconds, and we're going to label our points. So it's one full revolution, so point P will move as this circle moves along the ground. So what we need to see is the points at which the circle touches the ground. So I'll go with point 1 here, point 2, 3, 4, 5, and so on. Okay, so we're going to have basically 12 points. We come back to P again. Those points are equidistant. It's the same distance from P to 1 as it is from 1 to 2. So I'm going to step off that distance with my compass. So distance from P to 1. And as circle C rolls along the ground, that point 1 is going to move down. And now it's going to be on the ground line. Same if that is point 1 to 2. This is where point 1 was. Point 2 is going to roll down to the ground. And that's point 2. And they're going to be the same distance. So mark out your 12 segments all along the ground line. Now I'm going to stay zoomed in for the first couple of points, just so you see the process. Now, like the dynamic mechanism questions, there is a lot of constraints that are built into these questions. They remain the same. The distance from your point P to point 1 is going to stay the same even when the circle is rotated now to a new position. Same as the distance from the center to point P is going to remain the same. It's always going to be that radius 30. So our points here represent where the points in the circle have rotated down. Now what we need is put in where those centers are. And the center is always going to be directly above whichever point is resting on the ground. So if we bring out our center line and bring our points up to meet it, okay, now there's two ways of doing this. You can either draw in the full circle again at each one of those points, or you can just draw the arc that you need. So I'm going to do the full circle for maybe half of it, and then show you how to do the rest. Alright? So our constraint is the radius of the circle is 30. Okay, so the radius stays the same. And our center now has moved over to the center above 1. So this is my new circle now for point 1. Draw that in. This is point 1 now, and the distance from point P to point 1 will stay the same. So if I get the distance from point 1 to point P, and mark that off from where my new point 1 is onto my new circle, where they meet is point P1. Okay, so this is our new circle. Distance from 1 to P, this is where the new point 1 is. Mark that out. That's our new point P1. Now I can keep drawing in the circle, or I could just have put in that small bit of an arc from the center. Alright, so let's keep going with drawing in the circle. So our center now for 2 is here, and our radius is from the center to 2. We draw that around, keep it nice and light. Go back to your original circle. The distance from point 2 to point P will remain the same. It's not going to change. So distance from point 2 to point P. Mark that out from your new point 2, and this is my new circle. That is point P2. Now you just repeat the process. Same thing. Radius of the circle. Distance from 3 to P. Now points 3, 9 and 6 are going to be a bit special, a bit different, because this is the distance from P, or from point 3, and where it cuts, the circle should be right on the center line here. That's P3. And keep going on. So I'm going to show you actually now for point 4 what I mean by not doing in the full circle. So our center is, our radius is 30 mil. So for point 4, from the center, our point P has to be on that arc somewhere. Look, I'm not doing the full circle, I'm only doing an arc. The distance from point 4 on the original circle to point P on the original circle will be the same distance from 4 on our new distance out here, and it should cut through that arc I drew. And that is point P4. So you're going to get the same result, just you don't have all these circles drawn in. It's going to be neater. And I'm going to continue on with that process now. Again, the distance from the center, or your radius for the circle, the radius is always going to stay the same. 0.5, draw in your arc. Draw enough of arc to make sure that you actually hit your point. Distance from 5 to P. Distance from 5 to point P, and where they meet, that's your point P5. 6 again is a special one because it is directly above. Look, P and 6 are directly above each other. So if you draw your arc from 6 and draw a line straight up, it'll give you point P6. And now the rest is the same. You always get your distance from your point on this original circle to your point P on the original circle. Mark that out from where your new point is. Get the distance from the center to point P. In this case, it's always the radius. And mark it out from your center. With the two arcs across, they're your point. So I'm going to put in the rest of the points now. And your last point P does a full revolution, so it's going to end up on the ground again. So point 12 is your P down here again, and that's point P again. So there are your points. You make sure you label them so you know what to join together. So it goes from P to P1, P2 and so on. So join them in freehand lightly and then go for them strong. And that is the question done. Okay, so that is part B, the question done. Your locus of point P, and that is the path point P follows as your circle is rotating along that line. Okay, so hope that helped. If it did, leave a like, and don't forget to subscribe for more DCG tutorials in either ordinary level or higher level. Okay, thank you and good luck.